4.7 quadratic formula. Now you might be thinking, oh my gosh, I had blah, 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 and we learned a song with this. Mrs. Frickman does not sing, so just be prepared for that. So quadratic formula, this is opposite b, plus or minus the square root of b squared minus 4ac, a whole shebang over 2a. Now what does this actually find? Remember, this finds where it crosses the x-axis. So this would find this number and this number. If we can't factor it, or if I just can't think of the factors, this will also help me solve for the x-intercept. Same thing though, first, you have to solve for 0, or set it equal to 0. So I'm going to subtract over my 4. I'm going to also make sure that this is written in standard form. So my x squared, my x, and my number. I'm going to state what a is equal to. A is always the number in front of the x squared. My b here is equal to -1 because it's always in front of the x. It's subtraction, that means it's negative, and my c is equal to -4. So it's opposite b, so that right here would be a positive 1, plus or minus the square root. Now this is where you want to make sure to put this in parentheses. B squared minus 4 times a times c. This whole thing underneath the square root. Now this whole thing is divided by 2a. Now I will always, always, always tell you to do this portion right here in your calculator first. Now when you type this into your calculator, you want to make sure to have that parenthesis, -1. Notice how I close that parenthesis squared. Minus 4 times 2 times -4. 4. So that's going to be 33. So I have 1 plus or minus the square root of 33 over 4. At this point, you have to see if you can simplify this root. So I'm going to look at my factor tree right here. This would be 3 times 11. There's no pairs there. I can't simplify that any further. So I can't simplify this fraction. So I have two answers here. I have 1/4 plus the square root of 33 over 4, and I have 1/4 minus the square root of 33 over 4. Notice how I'm splitting this up into two separate fractions because it's this plus this side. So both of these are divided by 4, and this subtract. So I want you to try to do b by yourself right now. Now you might have gotten to this point and thought, oh, I don't understand what to do here. Well, I can take the square root of 0. Square root of 0 is going to give me 0. Now, if I split this up just like how I did here, I would have -6 plus 0 over 2 and -6 minus 0 over 2. And if you left your answer like that, I will give you not full credit, okay? You can always simplify a fraction. If you can simplify a fraction, if this is a perfect square, you must simplify it. So I have -6 plus 0 is -6 divided by 2, which would give me -3, and this will also give me -3. So what does this actually say? This would be like a graph at where x is -3, and either the graph, it's pointing up because it's positive, would be something like this. That means it's only touching right there because the vertex is right at that location. I want you to try to see by yourself. So you had to first add over the 4, find your a, b, and c. Again, it's a square root of 0, so you only have one answer because that means it's only touching at one spot at the vertex, so x is equal to -2. Try d by yourself. Now this one's a little bit different because I get here, I need to simplify this radical. So again, I usually do my factor tree over here. You can also do it with perfect squares. So you could have done, okay, 4 times 7. Again, I can either do, oh, I know this is the pair of 2's right here, or else I could have done it by the perfect square and taken the square root of both of these. So a pair of 2's comes out. So I still have this -4 plus or minus. This 2 comes out. I still have the square root 7 inside. This whole thing over 2. Now at this point, you can see if you can simplify. And this is where you look at your heart. If I can simplify that, all three of those have to be simplified. A number outside the root. Notice how I did not include the radical inside that heart. So each one of these can be divisible by 2. And when I divide all of these by 2, I get this. So my final answer would be -2 plus square root 2 and -2 minus square root 2. So those are my two answers. Those are the two locations that I cross the x-axis. Now something nice about the quadratic formula is the fact that right here, this portion underneath the root, that's not including anything else, that's called the discriminant. And this is actually really important information because if you remember when we got this at 0, we only had one answer. So if this is equal to 0, that's discriminant is equal to 0, only one answer. If this is a positive number right here, I'm going to be crossing the x-axis at 2 locations. Where they are, I don't know. But I will have 2 real solutions. If for some reason this right here is negative, then that means we're not going to have a solution at all. Remember on that pink sheet we had the fact that if it doesn't touch the x-axis, then there's no real. Emphasis on the real because we will get into imaginary. So if I want to just ask you, how many solutions are there? I can do the same thing that we've done before. Here's my A. My B here is -3. C is equal to 5. And I'm only checking my discriminant, which is b squared minus 4ac. So it's b squared minus 4ac. Again, when I'm plugging this into my calculator, you type -3, close that parenthesis, minus 4 times -2 times 5, and I get 49. So since this number is 49, it is above 0, and it's positive, so I'm going to have 2 real solutions. I want you to evaluate the next 2 discriminants. Remember, first you have to get this one equal to 0, and tell me how many solutions will it have. For the first one, opposite b, or b squared minus 4ac, you get -47. Since this is negative, no real solution. And for the last one, first you have to set it equal to 0, so subtract the 6, add the 9, equal to 0. And then you get this is equal to 0, 1 real solution. And there you have it, quadratic formula. I hope you have a great, grand, wonderful day.